Dear students, we are back with our class on geometric design course where we have been discussing about the intersection layouts. In our previous interaction, we talked about the channelization, and within channelization we have looked at two type of islands. One is the corner and the directional islands, or the center or the divisional islands. And towards the end we discussed about certain practical things which have been observed and the remedial measures which have been taken, so that the location becomes more safer and the traffic becomes more efficient. In today's interaction, we are going to talk about further elements here. The very first thing which we are going to look at is a pedestrian refuge island. Then we will be taking up the design considerations and the warrants which are required for making an intersection signalized. And then after that, we are going to talk about the various types of interchanges and the warrants or the feasible conditions for those. Let us start with the pedestrian refuge island. We have discussed about it previously also. These islands needs to be provided if their number of lanes are more than 4, because then it increases the width of the carriageway to an enormous value. So, if you have condition in this form and there is a median here, so the total space which is going to be crossed for the pedestrians is going to be quite high. So, it is 3.5 multiplied by 4 plus the width of the median. So, we have to take care of this and we have to provide it so that the pedestrians cross in one step up to this, and in second step they cross to the other side. The width of the island should be kept as a minimum of 1.5 meters. We have talked about 1.2 meters previously too, and in the extreme conditions we have also said that it can be 0.6 meters, but as far as possible we should try to provide 1.5 meters. And of course, these things, as I said previously too, when we talked about the pedestrian refuges or the zebra crossings, there we have said that it is also going to be dependent on the volume of the pedestrians and the spaces which are available in that area. And these islands, when you are going to provide, what we usually do is that we provide the gap in this form, so that the pedestrians keep moving at the same level of the carriageway, unless and until here we are providing some raised structure and the pedestrians are not required to come down and they can move from the level of the carriageway to the other side at the same level. So, when this is happening, then this particular section they are going to be curved. So, the vertical curves are provided along these islands. And another point is that so as to ensure safety of these pedestrians, illumination also need to be taken care of. So, that is a provision needs to be made. You can see here that there is a island here. It is provided with the gap so that the pedestrians can cross in either of the direction. It has been made safe by way of the provision of markings, and therefore, whatever vehicles are going to come here, they are going to deviate, so that the pedestrians are not going to be hit when they are standing in this area. When they are crossing, then of course, these vehicles have to give priority to the people who are crossing, and an orderly movement of the crossing people is being shown here, where one volunteer is taking the kids so as to cross the road. Now, what are the various considerations which needs to be taken care of? We have talked about few of the things already. So, we will just see that what are extra things which going to be there. The very first thing is that there are going to be various variations of the designs. So, we have to look at all of those variations of the island designs, and then we should see that what is going to be suiting more to the traffic movements, and it is making a safer environment, and that particular design should be taken. Another thing is that creating so many islands is not good. As far as possible, few large islands should be provided. The curved island should be there on all the important roads, and wherever there are intersections of the important roads, say on 2-lane roads. So, those particular locations, whatever these islands are provided, they should be curved as far as possible. But on these curved islands, the angle iron frames shall not be used, because they are going to be dangerous in terms of that if there is a hit, then it may create a major injury or a fatality. In case of the divisional islands, the approach width shall allow the smooth movement of the traffic. So, the divisional island has been there, and the traffic is coming from this direction, as we already talked about that the chevrons or the diagonal markings are going to be there. So, this approach width which we are talking, that should provide the smooth movement, Drainage is one aspect, that by way of the provision of these islands, the flow of the water, if it is there in this direction, should not hamper, and if there is a requirement of making some arrangement so as to move the water like this which goes to the other side, then those type of arrangement needs to be taken care of. Now, these are few of the designs which we discussed previously too, where we talked about what should be the length of the island, what should be the size of the markings in front of them with respect to the restricted approach widths versus the flared widths, and then we said that what is going to be satisfactory, what is not going to be satisfactory. So, we discussed about the total lengths, and we also discussed about these things and the restricted conditions which are going to be created because of the long islands being provided. But one thing which we have already discussed is that what should be the length of these islands when they are approaching to the intersection. So, 3 seconds of the travel time is being considered with respect to the approach speed. The similar conditions have been talked here. So, here this is going up to this point, but when it comes here, so there is more of a restricted situation. This also is smaller size, when then if it is come here, then it becomes satisfactory rather than a good design. So, in these forms what we found is that there are islands which are having the curves on the sides, or these islands have been delineated by the pavement markings, and there can be non-paved areas formed by the pavement edge which are supplemented by the delineators also, because then these delineators are going to define the objects, and therefore, the drivers are going to take different paths with respect to that object. Another thing is that when we are looking at these island designs, this island design is also related with the traffic volume, and it is also related with the volume in terms of movements. So, we have left, right and through movement. So, what is that amount which is going in either of these directions? Now, depending on this volume which is continuously increasing, so you have the future projections. Going by that, we have to see that how it is going to be progressively improved from time to time, and if it is being done, then the movement of the traffic can be smooth. So, this is what is being shown here in this diagram. What you can see is that it started with a very simplest condition, and then it has become smoother in terms of the radius being provided, or this turning radius which has been increased. Then further is the flaring being done here, along with these divisional islands being provided with the markings on the pavement. Then what we found is the divisional islands which are there, they have been also provided with the corner islands, so that the left turning traffic and the through traffic, they are got segregated. And then finally, when the traffic is quite high, then we are also looking at the right turning traffic requirements at this particular location, along with the size of the islands, because now this is continuously getting increased. And when we are looking at these things, then one thing which we have already discussed is, because this traffic is going to take a turn like this, therefore, this radius has been designed. Similarly, the traffic which is coming from this direction is going to take movement in this form when they go towards the right. So, the design of this nose has been taken care of with respect to the turning radius and the tracing of that turning radius on the layout of this intersection. So, this is also important, needs to be taken care of, not necessarily every time it is going to be like this, it may be different. Then when you have the right turning traffic of the large vehicles, we talked about that we should have a gap in the central reserve, and it should be extended by at least 3 meters beyond the extension of the curve line of the minor road. So, we have looked at this aspect, and we also talked about that the radius of the arc can be on both of the sides, where we are talking this side and this side is 12 to 15 meters, and the end of the central island should be bullet nosed. Now, here some of the things have been shown by way of the, say there is a vehicle which is standing here, or a vehicle which is standing here, which can be a single unit truck. So, if this is a single unit truck, then it is going to take a turn. So, there is a turning radii for that, and this is being traced for both wheel paths. That means, the inner and the outer wheel paths have been placed, and when it comes on this, then it should be clear of the center line. So, you can see that that is what is being ensured. Similarly, when it is going to take a turn here, then it goes clear of it and it remains in the lane in which it is supposed to go. So, this segregation is also there of these two movements, and the through traffic is moving continuously here. So, there can be a conflict here, there can be a conflict here, but the other conflict is not there. But at the same time, if the traffic is coming from here is goes, then this conflict. So, this is a smaller area here and a smaller area here, which may have these conflicts, which further can be removed. In this case, what you found is that there is a two directional right turnings are being shown, and with the nose of these islands, then the radiuses have been taken care of. So, you have these radius, turning radius being provided, and this radius should get into the center line of the cross street. The widths are 3 to 3.6 meters of these right turning lanes, and then there are width of the median we have already talked as a pedestrian refuse median, which is 1.2 meters or 1.5 meters desirably. So, those things have been shown here. Along with that, this particular gap, which is equals to the width of the turning lane, is 3 to 3.6 meters. This is one type of a design when the street profile has been considered. But if you look at the another one now, there is a small deviation here, and what you found that there is a offsets being used, and these offsets are 0.6 meters to 1.2 meters depending on the location. That means the extended condition versus the nose of the island, as well as it has been made curvilinear. So, we are giving more opportunity to the vehicle that the inner side of that vehicle in terms of a wheel path is not touching or is not creating a hazardous situation with respect to the nose of this island, even though these noses have to be displaced by a distance of 3 meters away from the tangent lines. Here, for example, which you can see that there is this type of system where the elevated road is being provided. At the bottom of the elevated road, there are crossroads, and for these particular things, then the various types of movements were there. So, the traffic is coming from this direction, can go in this, the traffic can come here and go in this, or even it can go in this form, or this can be movement in this. So, there are multiple movements which are happening at these locations, which are not good as such, because there are different directional movements, and therefore, there is a merging, weaving and diverging, all of the things happening there, and this may not be safe. So, what is being done is that this is an improvement plan, where the design has been made such that the U-turn is being provided on these directions, but if there is a continuous circular movement here, that is being provided on all along this particular rotary or the circle. Now, this example you can see that there is an island provided here, there is an island provided here, this is also another one, this is another site, but the size which is being provided is very high, and therefore, what you found is that there are these movements which are going to be there, various types of trajectories can be there which may happen, and multiple points of conflicts may arise in this one. Therefore, this total size of the intersection needs to be reduced in a manner that everything becomes more orderly. Now, let us come to the warrants for the signalized intersections. Now, these warrants can be defined by way of various criteria, and these criteria are related with the vehicular volume, the pedestrian volume, the requirement of a continuous flow on that particular intersection, or the accidents or the crashes which may take place, the history of that is available, or it may happen that instead of having the individual cases, there may be the combinations of these cases. Now, let us look at these particular points one by one. The first one is the minimum vehicular volume. Now, what it says is that on a major road 650 to 800 vehicles per hour in both directions, and on minor road 200 to 250 vehicles per hour in one direction. If that is the situation which is happening, then it warrants signalization of that intersection. The another point is related with the population, it is also related with the speeds. So, what it says is that if the 85th percentile speed on the major road is more than 50 kilometers per hour, then reduce the above values by 70%, and whatever values comes on the basis of that at a ground level the counts are available, examine them and take a decision whether the signalization is to be done or not. Or the another case is the intersection passes through a built up area of isolated community having a population less than 2.5 lakhs. And this one is going to be repeated and used in other criteria too. Now, if you look at the continuous traffic condition, then the values have increased. They have become 1000 to 1200 vehicles per hour both directions for major road and 100 to 150 vehicles per hour on a minor road. In fact, in the case of minor road, it has reduced. So, what we can see in the previous one, it was 650 to 800 for major road and 200 to 250 for minor road, but that is changing in the opposite directions. And if you talk about the built up area and the population in the isolated community, then this is less than 2.5 lakhs, that remains the same as such. But if you talk about this percentile speed, here instead of 50 kilometers per hour, it is considering now 60 kilometers per hour, because we are looking at the continuous movement, uninterrupted movement of the traffic. And here also, if this is a case, then the values can be reduced by 70%. Now comes pedestrian volume. So, what it says is, on a major road, if the traffic is 600 vehicles per hour and this traffic is both direction, or there is a raised median of size 1.5 meters with 1000 vehicles per hour both direction enters the intersection. In that case, along with 150 or more pedestrians who are coming from the highest volume crosswalks, if these two combinations are there, that means we are talking about a vehicle and pedestrian interaction. So, both volumes are being taken into consideration. So, one case is that we are talking about 600 vehicles per hour which are entering the intersections from the major road, or with a raised median of 1.5 meters if 1000 vehicles per hour are entering the intersection. In either of these cases, if there is a combination of pedestrian volume, again these values can be reduced by 70% if the major road has 85th percentile speed more than 60 kilometers per hour. Or the another case is that the built up area of isolated community population less than 2.5 lakhs is there, and that is, as I said, it is a common criteria across all of these three cases. Another thing is related to crashes, and here the history is being looked for 12 months, and it says that if it is 5 or more within 12 months which causes personal injury or property damage of rupees 2000 and more, then that location is requiring a signalized intersection. But this particular value is quite old, and maybe in future we are going to have a change in these particular values on the basis of the studies, because this was taken up way back. The combination, when you are talking, then this combination is minimum 2 or more if conditions are arising where 80% or more satisfied conditions are there, then also we can go for a signalization of an intersection. Now, let us change our track from at grade intersections to the grade separated intersections, which are interchanges where the ramps have been provided for different type of movements. As you can see in this photograph also, the traffic is going in this direction. So, there is a ramp for left turning, yes, gas goes straight. So, that is and it can take a turn in this direction, this traffic can come in this form, and the traffic coming from this one is coming in this. So, it is taking a right directional movement. So, there are different type of structures which have been provided, and when we look at these structures, then they can be defined in different forms. Now, when we go into those type of ramps etc., let us first of all have a division that what type of interchanges are possible. We have looked at few of these things when we talked about the classification of intersections. So, these are trumpet, diamond, cloverleaf, roundabout, directional, or there may be different combinations of these which are possible. So, what you can see is that there is a diamond intersection being shown at the top, there is a cloverleaf, full cloverleaf being shown here, this one is a partial cloverleaf, and then there is a rotary interchange being provided at the bottom, whatever you see on the right hand side. Now, when we are talking about the different directional movements, then they have been defined by way of the categorization of these ramps, and they are being given a name. Say, if we talk about the movement from this direction and we are going in this and we come in this direction and goes this way, this is defined as semi direct connection. But if you are coming from here and moving in this direction and take a turn and then goes in this is a loop. So, semi direct connection is allowing us to go to the right hand side and it taking 90-degree turn, But when looking at a loop, it is taking us to right hand side, but by a 270-degree turn. And there is a direct connectivity in terms of a diagonal connection from this direction and a diagonal from this direction, which are usually considered for left turning. There is also a possibility of having this type of a dotted structure, which is defined as a direct connection, and this direct connection is taking for right turning. But when you are doing this, then what you need to see is here is that there is going to be a further grade separation. So, multiple levels are going to be there, but if you have these type of multiple levels, different structures have been created one above the other, then the cost is going to increase a lot. So, with this thing keeping in mind that there can be loops, there can be semi direct connections, there can be diagonal connections, or there can be direct connectivities, let us go into the various types of interchanges. So, the very first one is a trumpet interchange, and this trumpet interchange, as you have seen previously also, are also being shown here in the terms of a sketch or a photograph. So, what it has is, it is a 3-legged intersection, and in these 3-legged intersections there are 2 right turns, one is negotiated by a loop and another is negotiated by a semi direct connection. So, this is a semi direct connection and this is a loop, and both are giving the right turning, and the left turning is going in this way. So, there are 2 diagonal ramps which are providing the left turning in an easier manner, and the ramps catering to heavy traffic volume shall preferably be provided with the direct connection. So, that is there, but then it all depends on the cost, it all depends on the money available with you, and then the spaces being required, because now you are going vertically up also, as well as you have the connectivity which is going to be at some other location. The another type design is a diamond interchange. Now, this diamond interchange is basically a 4-legged condition, and in this 4-legged condition what you can see is that there are at grade connectivities as well as the connectivities where you are going to have some grade separation. So, grade separation is there, the at grade condition is there, at grade condition here and here. So, 4 such conditions are going to be there, but because of this shape it is being defined as the diamond interchange. Now, here the ramp terminals on the minor highways, they are at grade and they are providing for right and left turning movements. So, if you are going from here this way, then at grade you are going to take a turn and then go into the right direction. So, at that particular location we have to see that what type of stop conditions or the markings or the signals etc. needs to be provided. So, ramps meeting the major road with one-way traffic movement are either curved or parallel to the major highway. So, these are all taking the one-way traffic actually, and when they are meeting here, so they are curved and then tangential in that sense. Vehicles desiring to take a right turn must come to ramp terminal and do stop start phase. So, this is what I said, that when they come at this location they have to stop first of all and then see the possibility of getting into the main traffic and then take a right turn. This requires less space and less costly because not many grade separating conditions are there. It is mostly used in a major minor connectivity. It has limited capacity due to at grade terminal on a minor road, and it can be improved by creating a split diamond or a 3-level diamond, but then it is going to provide the direct movements and it is going to be costly because of a leveled structure. So, here you can see that whatever we talked there. So, instead of considering the way the traffic is moving on this one, let us consider the way the traffic moves in a country. So, the traffic is coming from this direction. So, it can take a left turn and go in this way. So, we have this diagonal connectivity, but then the traffic which is desiring to take a right turn has to come to this location and then it is going to take a turn here. So, it is an at grade condition. So, the stop and go condition is going to be there at this location, and in fact, if it has come down wrongly, then there is a provision being provided by way of which it can again go and meet the main highway. So, here also the things may be happening at grade and here also the things are happening at grade. So, only one structure which is having a grade separated condition is being provided at this location. Now, the another case is of a Cloverleaf interchange. And in the case of Cloverleaf interchange, we have different type of things. One is a one loop ramp for right turning and one outer connection for left turning, which is being provided in each quadrant. Each quadrant means that you have 2 crossing roads. So, you have quadrant 1, quadrant 2, 3 and 4. So, one thing is that you are going to have a connectivity directly for a left turning, but another one is that you have a connectivity for this type of a movement from here. So, each quadrant has that two type of things, one for left turning and one for right turning. So, diagonal as well as a loop. So, vehicles desiring to take a right turn are required to move to the left and then go by 270 degrees. So, they are coming here, take a left turn and then take 270 degrees and then they go in this direction. This allows the continuous movement to interchanging traffic, no such intermingling is there. Most of the things in this particular area, they are having grade separation, only at grade condition is going to be there for these direct connectivities or diagonal connectivities which are taking traffic to the left. Design of weaving section between successive entry and exit is critical. We are going to look at what that means, and suitable is for major and major connectivities in the rural areas, and land requirement is going to be high because of all of these type of structures. And that is why, because the land is quite costly in urban area, we say that it is not so fit to be provided in an urban area. So, what we can see here is that there is this cloverleaf arrangement, and in this cloverleaf arrangement the traffic which is going in this direction, say if it has to continuously go, then it will keep going in this way, or otherwise it can take a turn here and go below this particular highway, it comes to this direction. So, it has taken on 270 degrees and it has gone to the right direction. Okay. Similarly, the traffic which is coming from here can go straight, the traffic which is coming from this one can go this way. So, there are different ways in which this traffic can keep moving, but what you can see is that the space which is required so as to provide this type of things is quite high, and the left turnings have been provided at this location or at another location, or this is the left turning. So, this is the total area, these left turnings are through the diagonals. Another category is the rotary interchange, again can be 4-legged, can be having more than that. It is having several roads intersecting at interchange and there is sufficient land available, then only we are going to have this. It may require the construction of 2 bridges. Main highway may go above or below the rotary intersection. The turning movements are through diagonal ramps, and it operates satisfactorily at a relatively lower speeds, and because of the way it is going a circular movement, it causes a little additional travel time or travel distance. You can see here that this traffic is going at the top. So, this is a grade separated condition, another road is going at the bottom. There is a rotary intersection, the traffic can move here in this way and get connected here. Similarly, on this sides, and the traffic can connect on this one. So, that is how the mechanism can be provided here for the different type of segregations, etc. This is another case where you can see that it is going up and then the traffic is going at a higher level and then meets or diverges. So, there is a traffic, it goes from here like this, or there is a traffic which gets here. So, the traffic from coming from this one has a conflict here. So, there is going to be a weaving area in this particular area, in this particular section there is going to be a weaving area, and here then the traffic can go out or traffic can keep get in, further going along the circle. So, there is merging, weaving, diverging, all of these things are going to happen in this one. Now, directional interchange is one of costly affairs here. The reason is that it is trying to provide you a separate connectivity for a separate movement, and because you are trying to do that, then what happens is that the levels keeps increasing, and that is ample clear from the diagram or this photograph which has been shown on the right hand side, where what you can find is that if you are coming from this direction and you have to take the right turn, then a right turning movement separately has been provided. If you are coming from this direction, then right turning going maybe in this one, here the left turning is coming in this form, or if you have to go to the right, then there is another structure being provided. So, at this level when you look at, what you found is that it is going to be a 3 or 4 leveled structure, and that is what is going to increase the cost, because when you go up by one level, and there is a road at the bottom, you need to have a clearance of something like 5 to 5.5 meters or even up to 6 meters, and when you go to 3 levels or 4 levels means you are going for 20 meters up. So, it is quite costly, but the efficiency of the system is going to be tremendous. It is a highly efficient operational system. There can be different directional interchanges which are being shown here, but you can see is that there is only for a single one particular case, or there is for this type of a loop condition, or there is a crossovers depending on that in which particular direction the traffic has to move. Similar crossovers with the diamond situations have been shown here. Here we can see that the left turning, because the traffic is coming here, a separate lane has been provided so as to come on this particular road, and there is another lane which is there. So, displaced systems have been created and they are separately taking the traffic, and similarly this is happening in the T junctions, Trumpet, or the total 4-legged system which is there, means from each and every leg there is a separate lane or separate structure which is taking you for separate movement. So, there are other designs too here. In this case you can see that this is a split diamond interchange, this is a half trumpet, this is a half diamond, the other side is not being created, this is half cloverleaf. It depending on which direction we need the things we can have it. This is a dumbbell interchange because 2 roundabouts have been utilized here for the movements. Again here this can look like a sort of a cloverleaf arrangement, is being named as Parklow A4 interchange. This is 4-level stack interchange. You can see here different levels are there and they are ensuring the directional movements. This is 4M Parklow partial cloverleaf interchange, and all of these things like they have been utilized, and this one is being taken from Road Australia condition. So, here also there are few of the things being defined. So, what you can see is that this particular section is actually elevated. So, this is a partial grid separation at 3-legged intersection, but if the traffic is coming from here is going to take a turn below that elevated one. Okay, so, this is partial system. This is another partial where again you have this as an elevated, and then the traffic can move from here from below it and similarly from this direction to this one. And because you are providing here this type of a structure so as to divert the traffic to a particular direction, what is being done, a flared system is being provided, and the traffic which wants to go continuously straight can take that one. This is a 4-legged condition where again the partial system has been provided at the center. The central lanes are elevated for both directional movements, and rest of the things have been provided at grade system. This is another case where the loops as well as the through traffic has been provided. So, right turning and the through traffic that is being taken grade separated, but rest of the things are there. So, this is a loop and this is a through traffic which is being taken. This is a complete one where we have already discussed about the trumpet. So, we have a change over here and the loop is also there, it is coming at the top, and that is how we are having a complete separation here. This is a cloverleaf arrangement where the all of these areas are grade separated. So, this is how it is being done in this case. So, we can continue with our warrants in the next interaction. So, we will looking at those things further. So, till then, thank you and goodbye.